Weird. All right, so we just completed that example 2, and that was it for example 2. All right. Oh, goodness. Good. Let's try example 3. I want you to try example 3 on your own. It's another one where, like example 2, where you're essentially given 2 points, and you have to find the equation of the line using those 2 points. Go ahead and read this and try to create the linear equation that it wants. Think of the number of grants as your X and the papers published as your Y. That's what it's saying. All right, let me go through this. When I was walking around, a lot of people were at least a good part of this. All right, so there were 354 papers published in Institution A, which received 86 grants. 86 grants is, money from the government, basically. So, if we were writing a ordered pair, and grants is like our X, and papers is like our Y, that would be the ordered pair 86, comma, 345 for institution A. For institution B, there were 898 papers, and they had 156 grants. So that would be the ordered pair 156, comma, 898. Sorry. So we want to create a linear equation like y equals mx plus b, where we have g is like our x value, p is working like our y value. So we take the slope, that's going to be 898 minus 345 divided by 156 minus 86. That gives me a 553 over 70, making sure I got those right, which is a value of 7.9. I calculate that. So I know my equation is going to look like P is equal to 7.9 times the number of grants plus B. In order to find B, I just take one of those points and plug them in. So I'll plug in the first one, 345 into the number of papers, 86 into the number of grants, so we get, 345 is equal to, this becomes 679.4 plus B. And when I subtract 679.4 from both sides, I get a negative 334.4 as the value of B. And so that means the linear equation that I'm trying to create is P is equal to 7.9 times the number of grants minus 334.4. Everybody else getting all those same numbers? Once I've created that linear equation, then I can use it to solve some other problems. I can say things like, how many papers would be published? Around how many papers would be published? If an institution received 40 grants, how many grants would we need if the institution needed to publish 1,200 papers? Go ahead and do those calculations on your own as well. So I'm gonna write this. Now, if the institution received 40 grants, then we plug in 40 into the G. What do you get as the p-value? Wait. Say that again.
Negative 18.
Negative 18.4, yeah. Negative 18.4. Now, that's a reasonable thing mathematically. In practicality, we can't publish negative amounts of papers. Probably what would happen, so this is an example that shows you some of the downfalls of doing modeling, right? We get answers on occasion that don't make sense in the real world. Publishing a negative amount of papers doesn't make sense in the real world. But mathematically, that's perfectly legitimate. In Moodle, if you got something like that, don't worry about it. It'll probably just type in negative 18.4 and it'll be fine. Now, on the other hand, this one does make sense. This answer will make sense. 1,200 is equal to 7.9 times the number of grants minus 334.4. I would add 334.4 to both sides, and that gives me 1534.4 is equal to 7.9 times G. Divide both sides by 7.9, and that gives me 194.23 grants. And again, you can't, likely you wouldn't say you have 0.23 of a grant, but again, that would probably be the answer that Moodle is asking for, just rounded to 2 decimal places. Funny enough that grants can be shared by institutions. So when you get, these government, grants, you can share it between multiple institutions. So actually a decimal place does in some ways make sense. There could be 4 different researchers at 4 different institutions, and they could each have 0.25 of the grant, if that makes sense. Anyways. All right, but the general approach I hope makes sense. Everybody following? Create an equation and then use that equation to solve some other question. All right, so example 4. Says the city's population is growing linearly. It had 20,132 people in 2005, had 34,114 people in 2022. Write an equation for the population of the city T years after the year 2005. Yeah, this is very, very similar to example 2, isn't it? Okay. And then it says, using this model, what would the population be in 2030? If this pattern continues, and then using this model, what year would you expect the population to reach 50,000? Excuse me, 50,000. Try, actually, since we're going to end early today, I'm just going to go through this right now. Does that work? All right. So 2005 is my starting year. So 2005 means a t of 0. And that means the fact that the population of the city was 20,132 in 2005 essentially means that we're going through the point 0, 20,132. Since the population in 2020 was 34,114, well, 2022 is a t-value of 17. So we get the point 17, comma, 34,114. All right, so if we're trying to find an equation, population is m times the time plus some b, like y equals mx plus b, where y is the population and x is the t, time after 2005. We can find the slope by taking 34,114 minus 20,132 divided by 17 minus 0. Now, when we do this one, we do not get a nice fraction. 13,982 divided by 17 does not give me a good decimal. It gives me 822.4705882, et cetera, et cetera. So I probably won't use the decimal version of this when I write the equation, because that would be a rounded version. I'd probably just use the improper fraction and leave it as such. What's my b in this case? Go for it.
Would it be the population in 2005?
Exactly. Population in 2005. If you plug in 0, you get 2132. So you don't even have to go through the process of plugging in 0 for t, because we know that's going to fall out. And then 2132 is going to be equal to b. So 2132 is equal to b. So the equation is p is equal to this 13,982 divided by 17 times t plus 20,132. Sometimes those slopes aren't nice, and that's the whole point of this one. Sometimes those slopes aren't nice. Population in 2030, well, 2030 is a t of 25, so we're just going to plug in 25 into that equation that I just found. And we're not going to get a real nice value. So we'll round that value to 2 decimal places. This is saying that the population should be about 40,693.0 0.76. Again, that's a rounded answer there. And then if we said, when will the population be 50,000? We simply put in our 50,000 into the population. And then solve. So I would take that 50,000, subtract 20,132. That gives me 29,868. And then when you're solving this, you can either do one of two things. You can divide by this entire fraction, so just divide by that fraction in parentheses. Or what you could do is you could multiply by 17 and then divide by 13,982. So I'm going to do that. I'm going to multiply by 17 and then divide by 13,982. You could divide by that entire fraction in parentheses. Rounding to 2 decimal places, I get 36.31. Remember, that stands for years after 2005. So when we're talking about the year or the time, that would be in 2041.31. So sometime in the year 2041, essentially. Okay. After the beginning of a year, but before the end of the year in 2041. Sometime in 2041, middle of 2041, the population should hit 50,000. Any questions about that? Again, read how Moodle would like the answer. Most of the time, it will be rounded to 2 decimal places, but sometimes it might ask for a whole number, year especially. So if it asks for a whole number year, you say sometime in the year 2041. If it asks you for a rounded to 2 decimal places, then it's 2041.31. Oh, project. We'll do one last problem today. And this is basically kind of similar to example 1, but we have 2 options. All right, so we're going to have 2 different equations. It says a salesperson is hired at a company, and there's 2 options for compensation. So meaning what he's taking away, right? His salary, or her salary, I guess. Option A has a base salary of 50,000 plus 10% commission on sales. So option A is that. Option B is a base salary of 75,000 plus 5% commission on sales. So what is the total pay in each option if the salesperson sells S in sales. You have to know how commission works. If I sell $100 and it's 10% commission, I get $10. If it's I sell $100 and it's 5% commission, I get $5. So option A is a base salary of $50,000 plus 10% commission. So the pay there is going to be $50,000 plus a 10% commission. Anytime you're talking about percentages, 10% of something, you have to change it to a decimal, in this case, or a fraction. I use the decimal most often. 10% is 0.10, so 0.10 times S. Option B is $75,000 plus a 5% commission on sales. That's going to be 0.05 times S. And then it says, what is the pay for each option if the salesperson sells $200,000 worth of goods? And then how much would the salesperson need to sell in order for the two plans to be the same? So if we want $200,000 in sales and we want to figure out what the payment out is, option A, we're just going to say that the $50,000, we have to take 0.10 and multiply it times 200,000. Option B, I do the same thing except for the equation in option B. In option A, his total pay or her total pay would be $70,000. In option B, the pay in that scenario would be $85,000. So if this salesperson sold $200,000 worth of goods, then obviously their payment in option B would be better than their payment in option A. Then it asks, when would these be the same? How much would the salesperson have to sell in order for these two to be identical? How do I figure out when these two become the same?
Just set them equal to each other.
Exactly. Just set them equal to each other. When it's this P equal to this P, it's basically when is this equal to this, right? When is the output here equal to the output there? So when is the function output equal to this function output? So all I have to do is set those two things equal. And then solve. So what I would do is I'd subtract 50,000 from both sides, and then I'd also subtract 0.05s from both sides. If I did that, I get 0.05s. So again, I'll write that, I guess. Subtract 0.05 times s. 0.05 times s. That gives me 0.05s. Subtract 50,000. Subtract 50,000. That gives me 25,000. And so, in order to solve this, I take that 25,000 and I divide it by the 0.05. Oops. Hit the wrong thing, my calculator. And that gives me 500,000 as the s. That means if this salesperson has $500,000 worth of sales, then both payments would be the same. Both payment plans would be the same. Now, I want to point out something. Here we were under 500,000 and option B was better. It turns out that, again, intuition tells you, but also the numbers tell you, that when you get higher than 500,000, then option A is better. Okay. So below 500,000, option B is better. Above 500,000, option A is better. So if this were a decision this person would have to make, they should think to themselves, well, am I going to have more or less than this 500,000 in sales? If they think they're going to have more, then take option A. If they think they're going to have less, then take option B. That makes sense? Good. All right. Like I said, we're in it a little bit early today because of school cancellation stuff. So there's a school cancellation for 3 hours. I will be in my office hours within, I'm guessing, 30 minutes. Got to go grab something. But so if you do have any questions, you want to be in my office, want to meet me in my office, I will be in my office in 30, 40 minutes, something like that. Okay. All right. Other than that, we'll cover anything we haven't so far in 2.3, and we'll cover 2.4 on Thursday. Okay. I'll see you then.